All right, so this is our second part of the fundamental theorem of algebra, which is building polynomials. I've included a couple of theorems here at the beginning, one about the complex conjugate root theorem that says if we want a polynomial with real number coefficients, then complex roots have to come in conjugate pairs. That's going to help us with this problem that we're going to be working on here. The other one says that the irrational root theorem says that if we are going to have rational coefficients, and notice in the first one it was restricting to having real number coefficients, going to get a little more restrictive here with the rational coefficients, and that if we have a root that looks like a plus or minus b times the square root of c, something in a form that we would see from a quadratic formula, then we also have to have its conjugate in there as well. So in a problem like this, where it says, write the simplest polynomial function with the zeros of 1 plus I, 3, and square root of 2, it means that the 1 plus I is not alone, but there should also be a 1 minus I, and the square root of 2 is not alone, there should also be a minus the square root of 2. All right, so let's get started. To begin with, when we're putting these together, it's always x minus whatever our 0 is. So we have an x minus 1 plus I. And I'll put in the x minus 1 minus I next to it, because we're going to multiply those together. They'll make a cleaner answer for us if we do. And we also have an x minus 3 in this one, and then we have an x minus the square root of 2 and an x plus the square root of 2. So this is going to be a degree 5 polynomial by the time that we're done with this. So let's start building our polynomial. We'll distribute up here, so I get an x minus 1 minus I that I'm going to multiply by an x minus 1 plus I as we use the area model to figure out what this is equal to. So that gets an x squared minus x minus ix minus x plus 1 plus I plus ix minus I and minus I squared. And so we start to combine some of those things together. We can see that the minus ix and the plus ix will cancel, and the minus I and the plus I, and that minus I squared is equivalent to, since I squared is negative 1, that's a plus 1. So if we pull these things together, we're going to get the x squared minus 2x plus 2. That's what we get when we multiply those together. Now, let's go ahead and we will do the x minus root 2 times the x plus root 2. With an area model there as well. That'll give us an x squared minus root 2x plus root 2x and a minus square root of 4, which is 2. And we can see that from this, these are going to cancel each other out, and that's just going to leave us here with an x squared minus 2 for that part of the problem. So let's go ahead. We will multiply those two together. So let's take our x squared minus 2. Okay, so I'm going to do that a little bit differently. I'm going to put the x squared minus 2. Doesn't really matter where I put it. And I've got an x squared minus 2x plus 2. And we will multiply those together. See what we get. Now, we could have left a 0x in here. We're missing a power of x, and that would make diagonals line up a little cleaner for us, but we should be able to do it this way just fine as well, as long as we're careful and pay attention. So we've got an x to the fourth there. We've got a minus 2x squared there, minus 2x cubed, plus 4x there. plus 2x squared and a minus 4. And if we combine those pieces in, I'm going to write those up here because I'm going to use them here in a second. I've got an x to the fourth. I have a minus 2x cubed. I've got a minus 2x squared and a plus 2x squared, so those cancel each other out. And show that on here. We have a plus 4x and a minus 4. So all that remains is to multiply that by our x minus 3. We haven't done that one yet. So let's bring the x minus 3 down here. Build our area model. And fill it in. So we've got an x to the fifth, minus 3, x to the fourth, minus 2, x to the fourth, plus 6, x cubed, plus 4, x squared, minus 12x, minus 4x, and a plus 12. So my final polynomial should be what I get when I add all these together. So I get an x to the fifth minus 5x to the fourth plus 6x cubed plus 4x squared minus 16x plus 12. And that, p of x, is our simplest polynomial that has the roots that we have listed there at the beginning.